Hello, Judson students. Let's take a look at our lesson for Math 110. This is section 3.1, part 1. Okay. The topic is linear functions. So we're talking about lines today, everything we know about lines. Okay. When collecting data, always try to keep the independent intervals consistent. Then if the dependent variables are constant, you have a linear function. Okay, so this is just a way to look at it visually without actually having to crunch some numbers. But let's take a look. Let's do an example. Let's just do x, y, t table. Okay, and we're going to start with, this is given 0, 3, 6, 9, 12. Okay, and this is 2, 4, 6, 8, and 10. Okay, so which is the independent variable? Remember from chapter 2, which has been a little while, remember x is the independent variable. Independent. And that makes y the dependent. Okay, so independent, and then y is the dependent. Okay, and they say try to keep the independent variables consistent or constant, either way. And so what that is saying is the intervals from 0 to 3, 3 to 6, 6 to 9, 9 to 12, are those consistent? And we would say yes, right? The change is 3. Okay, so remember that's when we use this fancy notation, delta x is 3. Okay, and then how about the dependent variables? Is the change constant? And we would say, yep, the change is 2. So the change in y is equal to 2. And so if the change is consistent here and the change is consistent here, this is a linear relationship. Okay, let's talk a little bit more about lines. Let's see, what else could we write? What is this? The change in y over the change in x. That is slope, right? That's slope. That's the same as, let's write everything that's the same as y2 minus y1 over x2 minus x1. Okay, that we call slope. We also can call it a rate of change. And we can also call it growth rate. Okay, those all mean the exact same thing. So in Algebra 1, we like to use the word slope, but when we're talking about real situations, then we like to call it rate of change or growth rate. Okay. And then let's look at y equals mx plus b. Okay, this, actually we could also do this too, right? This, another thing we could write, this is m. Okay, so all of this stuff is m. Different ways we can write it, all different ways of saying the same exact thing. Okay, and then b, same thing, like in Algebra 1, we called b the y-intercept, but now kind of in word problems and different things, we're going to call it the initial value. This doesn't have as many names as this up here, but we just kind of call this the initial value, kind of the start of the problem. Start of problem. Okay, good. And those are the two things that make up a line. I think that's good. Okay, so let's take a look at our first example and see if we can kind of put all this together. We can refer back to this paper, and this is kind of like all the information about a linear function. All right, so let's get page 2 here. Okay, Robins fly south in the winter and then come back in the spring. Sue recorded how many robins she saw each day starting March 1st. Let's see. She did this every 2 days. Okay. So is this relationship linear? So what they want us to do is see, are these consistent? And are these consistent? So this, I think, is even a little bit easier. This is definitely consistent, right? Every 2, we're good to go. All right, how about the y values? The y values or the dependent variable, are those the same? Maybe a little bit harder, but we could always subtract. 11 minus 5 is 6. 17 minus 11 is 6. 23 minus 17 is 6. 29 minus 23 is 6. So those are consistent. Let's see, we could write, is that a linear relationship? So we could say yes. Explain, we could write something like the growth rate of the number of birds seen is constant. And maybe what we could do is, why don't we show this growth rate? Let's go ahead and show the growth rate. And remember, the growth rate is nothing more than slope. Okay, so let's write growth rate. We'll show them that this growth rate is always the same. Growth rate, which is m. There's a couple ways to write it, right? We could do y2 minus y1 over x2 minus x1. We could also just say, you know, visually, you could actually just say, hey, I know the change in y, just make sure you do y on top, over the change in x. Change in y, make sure y is the, remember this is x and this is y. The change is 6, and the change in x is 2. If you like this formula better, this one I just kind of visually saw the change, and here I just saw the change, but if you want to use this, you could do 11 minus 5 over 2 minus 0. Okay, and that would get, and the nice thing about this is it works for any point. So let's say you said, hey, I want to do this. You want to do 23 minus 17 over 6 minus 4. Okay, those are all the same. In fact, they have to be the same, right, if they are linear. Okay, and so this equals 3. Now, what does that 3 mean? The rate, the growth rate is 3. So 3 more birds each day. So that more than kind of explains. We did a little bit of sentence, but then we actually showed what we meant by the growth rate. We proved that the growth rate is always 3. Good. All right, let's try the next one. All right. Slide it up maybe a little here. Okay. What does this one say? Let H denote the height in meters of the winning pole vault in the early years of the modern Olympic Games. We think of H as a function of the number n of Olympic Games since 1900. An approximate linear formula is this. Identify the initial value and growth rate and explain in practical terms the meaning of each. Okay, so we want to know the initial value. Okay. What is the initial value? Well, if we go back to, we can actually just go back to this for a minute. If we go back to this, remember, your initial value is always this number by itself without the x, because that's the start of the problem. So the initial value, if we want to just read here, the initial value is 3.3. And I think that represents meters. Okay. That's how high they were jumping in 1900. Okay, that's how high they were jumping. Now, the goal is right every year, everyone always tries to jump a little bit higher. And that's what this 0.2 is representing. Each game, on average, just on average, but each game, it always seemed like not only did someone jump a little bit higher, but on average, it was 0.2 meters higher. Every game, people got better, they worked harder because they knew this is what they had to beat. And on average, every time they played the Olympic Games, they increased their jump by 0.2 meters. And so that is then the growth rate, right? The growth rate is how much it increased each time they played the game. The growth rate each time they played the game, or again, we could go back. Remember, slope is always growth rate, and slope is always a number right in front of the variable. So 0.2 meters. Okay. And so, let's see. We can explain just a little bit. So this, we could write kind of what we just said. 3.3 meters was the highest jump in 1900. Okay, and 0.2 meters is how high each new jump increased by. Okay, that should be good. The main thing is picking out, this is the initial value and this is the growth rate. Okay. All right, let's try number 3. For my daughter's wedding, I pay $500 to rent the building and then $15 for each guest. Using G for the number of guests and C for the cost of the wedding, find a formula for C as a linear function of G. Okay, so it's automatically going to be C equals, and then I'm going to have G over here. We can even start out writing it like this. Let's see, I don't think this will take up too much room. All right, so y equals mx plus b. That's what we're using. It's a linear function. It's a linear equation. So that's what we need. Now the only thing is they're telling us to use C and G. C is a function of G. This written right here is Y as a function of X. So the only thing that changes is this is going to become C, and then my X is going to become G. Okay. Now I need to fill in this back number and this number. This is the initial value. Initial value. What do we start out with? What's our starting value? And then this, I have to figure out my rate. Okay. And keep in mind, maybe this might help if we call it literally the growth rate. This is the growth rate. So when we just walk in, how much are they going to charge us just to rent the building? Okay, if I technically had no one come to my wedding, I would still have to pay $500. And that's what we mean by an initial value. I have to pay $500 no matter what. Okay. And then every guest, $15. So if it's 3 guests, I have to take 3 times my 15, and then I can add the 500. Okay, if I have 10 guests, I have to take 10 times 15. So that is my growth rate. And there you go. You can see why this is the initial value, because if I don't have any guests, if this goes to 0, this goes out, and my cost is still $500. As soon as I have 1 guest, then I take it times 15. If I have 7 guests, take it times 15. Okay, so that's a linear function. Because it fits the form y equals mx plus b. That's linear. All right, let's try, let's see, I think that was it for that one, right? Okay, let's try the next one. All right, here we go. All right, what does it say? Joel is a salesman. He earns a base salary of $1,800 per month plus 3% of his total sales for the month. Write a linear formula that gives monthly income in terms of sales. Monthly income in terms of sales. So that means originally I was going to have y equals mx plus b because that's linear. If it says linear, it's got to be y equals mx plus b. Now, they want us to change these variables. Income in terms of sales. So that's income in terms of sales. And that S is in terms of. So I need an initial value and I need a growth rate. Initial value and growth rate. Okay, so if he doesn't sell anything, that's, remember this, the initial value, that's where we start at. So if he doesn't earn anything, he's still going to get a base salary or a salary of $1,800 a month. So I equals 1,800. Okay, and then the sales, his growth rate is 3%. So how do we make percent a decimal? Move it 2 places to the left, so 0.03. And that's it. If it fits y equals mx plus b, you've got a linear equation. We've got initial amount and growth rate. All right. Sarah is in sales also. Her salary is completely based off of her sales. She has no base salary, but earns 26% of her total sales for the month. Write a linear formula that gives monthly income in terms of sales. So same thing. We could write y equals mx plus b. We know they're just changing variables here. Income in terms of sales. But what's her initial value? What does she get if she doesn't do any sales? She doesn't, there is no base salary. So B is actually 0. And that can happen sometimes. That's okay. And then her growth rate, 26%. We just have to make it a decimal. So make that a decimal, 0.26. S. The 0 is optional. If we want to just use 0.26s, that's okay, right? Because adding 0 doesn't change anything. Okay, if both sell $5,000 in 1 month, which person made more money? Okay, so Joel's income, that's what we're looking for, right? Made more money, that's income, so we're looking for I. We're going to go back up to Joel's, 0.03 S. But what is S? S is how much they sell. So S is 7,000. And then plus 1,800. Okay. And then Sarah is the other person. Sarah's income. We're just going to read it right off of this one, or we don't need that plus 0, so we'll just read it off of this. 0.26. And instead of S, it is 7,000. Okay, so now just grab a calculator. Make sure your calculator either does order of operations or make sure you do this first. Let's see, this should be total. Well, let's see, I can write it. If you do this, I got 210. So total, his total income for the month is $2,010. Okay, and then Sarah's, you just literally multiply those two together. I got 1820. So Joel's rate was so small, but at least he gets to start out with 1,800. Sarah's rate is actually pretty big, but starting at 0, she's got to make sure that she makes a lot of sales. So at this point, Joel, if they only sell 7,000 a month, Joel is still doing better. Good. All right, let's try 5. All right, what does 5 say? The temperature at 6 a.m. on a certain summer day is 64 degrees Fahrenheit. Over the morning, the temperature increases, on average, it should say, by 3 degrees per hour. Using T for time in hours since 6 a.m. and F for temperature, or Fahrenheit, find a linear formula that gives temperature in terms of hours. Okay, then use the formula to give the temperature at 11:30. Okay, so we need y equals mx plus b. And the first thing we need to do is change it to the variables that they prefer. Let's see, find a linear formula that gives temperature in terms of hours. But they used what for temperature? They want us to use F for Fahrenheit. So temperature in terms of hours, but they want us to use T for time. Okay, so whatever comes first in terms of, then that comes second. Okay, we could have did T for temperature, H for hours, but they specifically requested, so just read whatever the book is going to request, Fahrenheit in terms of time. Okay, so now this is just gets maybe a little bit harder. Let's see, do we have, oh, we're actually okay. What's the initial value? Remember, initial value and rate. This one isn't too bad. We know that the initial value, what's the initial temperature? 64. So F equals, and even though it's the first thing we always write, they put it at the back. So who knows, 64. And then T is going to stay because that's always changing. And what's our rate? Our rate is 3 degrees per hour. Okay. So what does this whole 6 a.m. come from? Well, that's going to help us with the 11:30. What we need to figure out is how many hours it is. Time is how many hours from 6 to 11:30. So our equation is done, but now we want to use that formula to give the temperature. So how many hours is it from 6 to 11:30? Well, 6, so 7, 8, 9, 10, 11, and then half hour, so 5.5. Okay. So the time, the only reason we need the time is we just need to translate that into hours. Okay, we have to know that this problem starts at 6 a.m. So this is only accurate, and that happens sometimes. Sometimes your equations aren't accurate all the time, so you just have to make sure that you read or give this person information that this is accurate, at least starting at 6 a.m. Okay. All right, so then we just go use it. Fahrenheit equals 3, time is 5.5 plus 64. Just make sure that you don't plug in 11:30. That's no good. Time is always hours, minutes, or seconds. So we had to convert from 6 to 11:30. We had to convert how many hours that was. Let's see, I think I just have a final value. So just make sure you do this, multiply first and then add. And that takes us to 80.5 degrees Fahrenheit. Okay, and that's the temperature at 11:30. Okay, good. All right. Let's see. Trying to see how many pages I have. All right. How are we doing here? 6. Okay. So 6 says what? Suppose your car's 20-gallon tank is full when you begin a road trip. Assume that you are using gas at a constant rate. So the amount of gas in your tank is a linear function of time in hours that you have been driving. After traveling for 2 hours, your fuel gauge reads 3/4 full. Find a formula expressing gallons of gas as a linear function of time. Okay, so we know linear, we know it's going to be y equals mx plus b. We know a formula expressing g as a linear function of t. So whatever comes first, g as a linear function of t. Okay, so what does that mean? We need to find an initial rate, and then, we need to find an initial value, and then we need to find the growth rate. Initial value and growth rate. Well, initial value. How much, when we started this road trip, how many gallons of gas do we have in the tank? And that is 20. Okay, so G is equal to 20. This value and what this is representing, they'll always do the same thing. So this G was gallons of gas. So not only is this the initial value, but this is the initial gallons of gas. Those two actually always go together. So if you really get stuck, initial value, if you're like, well, what value is it? It's whatever this represents. So this is the original amount, specifically in this problem, of gallons of gas. So that might help a little. Okay, so now we need the rate. We need the rate. Now we have to pause for a second. We have to think about this. What happens to your gas tank as you drive? The gas goes away, right? As far as in your tank, the gas gets used up, burns up so that you can move. So in this problem, this rate is going to be negative. In this problem, it's going to be negative. And what we're going to do is we're going to make a little XYT chart. Okay. So let's also write, what does this stands for? Let's actually make this T, because that stands for time, and this is G, this is gallons, right? So let's even write that this is time and this is gallons. Okay. So when time is 0, okay, when time is 0, that is the start of the problem. When time is 0, that's the start of the problem. So you have 20 gallons of gas. Okay. Then what does it say? After traveling for 2 hours. So now your time is 2 hours. This one's kind of tricky though. This one says now you have 3/4 full. So what you had to do is you have to actually go off to the side and figure out how much is 3/4. So to figure out this, you have to go off to the side and you have to do 3/4 of 20, because 20 was your original amount. And now you don't have 20, you only have 3/4. Okay, so to figure that out, you would multiply 3, you can multiply straight across, so that gives you 60 over 4, and that, and then if you reduce that down, that goes in there evenly, so that is 15. Okay. Okay, so now we have a couple ways we need to find out. So we could do y2 minus y1 over x2 minus x1. Or you could just take a look, how is it changing from here to here? How is it changing from here to here? Okay, you could do either way. If you are like, you need it more visual, then you're going to want to do y2 minus y1 over x2 minus x1. And that might actually help to catch that it's going to be negative, because this will be, we'll put it over here. I'm running out of room. This will be 15 minus 20. Over 2 minus 0. And so that gives you negative 5/2. Okay. Otherwise, if you check here, you can see that this is going down. So that is the negative 5. And then this one, so like this, I guess we would actually do it this way. If we go this way, this is negative 5. If we go this way, that is 2. Okay, it's okay to read it just like that if you don't want to actually do the math. This way is negative 5 and this way is 2. And so that's change in y over change in x. And so that is your slope. Negative 5/2 t plus 20. Okay, you can just do it change in y over change in x, or you can actually work it out. That one was a little bit harder. Okay, 7 is kind of a trick problem. Let's see. It says the depth d in inches of snow in my yard t hours after it started snowing this morning is given by this formula. Okay, this formula is telling them how much snow that they had. Okay, if the depth of the snow is 7 inches now, what will be the depth 1 hour from now? This formula gives you the depth. Okay. But what they want you to do is to look at the equation. This, what do we call this, guys? This is the growth rate. This is the growth rate. That's how many inches it's changing every hour. That's how much it's changing every hour. So if I start out with 7 inches, how much is it going to be in an hour? This number is the growth rate. So they don't want you to necessarily use this equation. They want you to just realize that, hey, this is my growth rate. And that's what that means. They kind of want you to dissect the equation and say, hey, that's my growth rate. That's how much snow is falling every hour. So if they want literally 1 hour from now, it's 7 plus that growth rate. So 8.5. Okay, so they don't actually want you to use this equation. You could use this equation, but it's hard because you have to come up with time and different things. But they want you to realize that the growth rate you can pull out of that equation and kind of use it on your own. Okay, so look for that one on the homework. There's one similar to that. Okay, what is 8 saying? The table below shows how much it costs to ship a package based on its weight with Packages R Us. Okay. Let's see. Find a formula. Oh, this is our last one, guys. Okay. So find a formula for the linear function giving price to ship in terms of weight. Okay, so price in terms of weight. I don't think they said W, but usually they'll tell you, so we'll go ahead and use W there for that. They probably should have told us that. Let's see. Find, okay, formula for price. So let's do y equals mx plus b. Okay, and we're going to do price in terms of weight. Okay, so what is the initial value? Remember, initial start of the problem. And remember, if you get really stuck, remember this number correlates to this. So what is the price at the start of the problem? What is the price at the start of the problem? Oh, that's what this is. If I don't weigh it at all, if I just walk in, I gotta pay $5. There's like a baseline fee. And so that's what that initial amount is. $5. Okay. All right, so now slope, kind of like, what can we see here? Kind of like what we did here. Okay, this is kind of nice. We can, we just want to see what this changes. Okay, and then we want to see what this changes. Okay, and so we can either do it, we can just kind of look at it and kind of estimate it, or we can actually use, because we're trying to find slope, we can actually literally do y2 minus y1 over x2 minus x1, which is the same as the change. And I think the bottom's easier to see. What is the change? The change is 2, right? If we want to show that, we can do 2 minus 0, we could do 4 minus 2, we could do 6 minus 4. Doesn't matter. So let's, we could just pick these first two, might as well. Okay, so let's make sure that was on, just make sure that's on the bottom. X always goes on the bottom, so 2 minus 0. All right, so if we're going to use this, then it's 11.2 minus $5. And if you're just kind of thinking of it mentally, what's the change in this? You just automatically, if it's something you can't see visually, then you would actually do 11.2 minus 5, which is actually what we literally just wrote. Just like here you can see it, right? But let's just say to prove to someone, you would do 2 minus 0, or 4 minus 2, or 6 minus 4. Okay, so on the bottom, if it's not easy to see visually, then you just have to do the subtraction, 11.2 minus 5. Okay, all right, so grab a calculator. That turns out to be, well, we probably could do that. I think that's 6.2 over 2, and then we can reduce that down to 3.1. Okay, so what is that 3.1? Well, first of all, it's slope. Second of all, it's our rate, our growth rate. Okay, and just in general, what does it mean? Well, I walk into Packages R Us, I pay $5. The weight, how many ever pounds my package weighs, I take that times $3.10. So it's how much more money I have to pay depending on the weight. Okay, and I think that's our last thing, right? Use this formula to find out how much it'll cost to ship a package that weighs 22 pounds. Well, guys, you only got two variables here. Just be careful, because the P, does a P stand for pounds or does it stand for price? And this one, so just always take your time. That stands for price, because the W is actually deals with weight. So you just kind of have to be careful there. But so it's one of these two. It says how much will it cost, so that's, we're looking for price when the weight is 22 pounds. Okay. Just multiply that and then add 5. Let's see if we can still get it on here. And that should be $70.10. Okay, so a 22-pound package is pretty darn expensive, but that's okay. Right, usually, I know I don't know if it's $70, but I know on Amazon they do definitely do things with weight, right? And things that are heavier, they do a lot of times charge more, or it won't be prime because they want to charge more if it's heavier. Okay, guys, we've officially made it through our first lesson. Now you want to go to WebAssign and finish, let's see, it is what? Section 3.1, Part 1 on WebAssign. Good luck.